Okay, and so I see that you have an equatorial mount, so are you planning on doing any photography today?
Yeah, I'm gonna image with my Canon DSLR, which will be directly attached to my reflector, and I'll take some photos.
Okay, so we are about an hour and a half, 2 hours from polar alignment.
Okay.
So can you tell me why is that important for you to do polar alignment?
Because the Earth is moving. As you know, Earth is rotating along the axis of rotation of the Earth is aligned to Polaris. So if I align my mount to the Polaris, it can track exactly the same rate as the Earth's rotation. So when this telescope will magnify a lot of the image. So without that alignment and the tracking, the image will be trailing. So I need to align the mount.
So how long does that allows you to do more exposure because your mount is polar
without
aligned?
it, maybe you can do 1 second, maybe a couple of seconds maximum. But carefully polar aligned, you can like make 20 minutes exposures or something like that.
So usually, what is the exposure time that you do when you do your imaging?
I've been doing for 5 minutes, especially in the city. If you go longer, the image will be too bright. For the dark skies, you can go like a deeper, like 10 minutes, 20 minutes.
So what you're saying is you get the light pollution in your image, and it's difficult to remove after.
Yeah, it's almost burnt. Yeah.
Get that orange glow, right? In your
it's
image.
orange. Is sometimes you go too long, then it go white.
It go white.
Yeah.
Yeah, obviously.
Yeah.
So what other goodies do you have to power all this equipment?
So this controller can command the mount to point the object that you want to image.
Now, in order to not induce vibration when you take this exposure, you are remote controlling the camera, I believe.
Yeah, but I don't use remote shutter. I use the laptop to do that. So laptop has the software to control my DSLR.
Six-inch oil space triplet from Astrophysics, and we're going to I think we're going to title this East Meets West.
Is that
East
true?
is the Esprit 150 and the West is the Astrophysics 6-inch.
That's right.
So what kind of mount you have?
I have a combination Lost Mandy mount tripod with a Astrophysics 706 manual tracking mount. So I'm just getting a...
So you have a step motor separately from the mount?
Yes, it's just it's a tracking only, with no polar alignment and no digital circles or...
So it's like a big expensive watch.
Yeah. Yeah. Oh, man,
if you don't get eaten by all the bugs before you set it up.
So we have a few people coming to officiate so that we have a unbiased opinion. Because everyone seems to like their own scope, and it's always important to be able to step back and look at the facts and be honest.
Be honest, I like that.
Be honest, yeah, because the main thing is one scope can't do it all.
So do you know how much it weighs?
It weighs about 35 pounds the way I've got it loaded up right now.
So you can't really just hold it in your arms?
No, 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 no. Well, I mean, you could if you're Arnold.
So it's about 9 o'clock. It's about an hour from being able to see the North Pole. Can you tell us why that's important?
Well, because I need to do it a polar alignment, because without a polar alignment, you can't figure out where the center of the rotation of the Earth is. And without that, your mount is not going to track accurately, because it's not going to be able to rotate in a clockwise motion to go with the Earth.
So to make it in simple terms is that if you want to keep the object in the field of view,
yes,
you need your tracking to be as
fairly accurate for visual, but Not as accurate for astrophotography. That has to be very, very accurate.
But you're not doing that tonight,
No,
I think.
not doing that tonight.
So we're about, I would say, 1,500 meter elevation, or
We are at 3,000
feet, right?
3,000 feet.
3,000 feet elevation.
Yeah, so it's about just about 960 meters.
And so we're trying to be above the Siberian smoke that we still having here in Vancouver.
Yes. I'll get you. Take that, take that, take that.
It's the battle of the bug. It's not the battle of the scope.
No, it's not about the scope now. It's about survival.
All right, Keith. Well, we'll catch up with you once your setup is more
Great.
more done. All right, Keith. So now that, in the interest of time, we kind of move forward.
Yes.
Your setup is all done now.
No, it's just, well, it's the physical setup. Now the alignment, we wait for Polaris.
Yeah. So we talked about that earlier. So
Yes.
we're waiting for the North Star to appear in the sky,
right.
so you can do your polar alignment.
Yes, that's what most people are waiting for here that have German equatorial mounts. So without that, there's no way to for the computer to find things or to be properly lined up for any kind of high power viewing.
So I see that you have a right angle finder on your scope.
Yes.
So can you talk about that a little?
Okay, right angle finder I find is more enjoyable than a straight through. Manufacturers haven't got the point yet, especially the East. They seem to think that straight through is just fine, but I find that it's easier to look down into there at extreme angles than to try to bend over and look up. Same with the diagonal, it's just comfort.
So talk about your eyepiece that you're using today.
Right now, to do the polar alignment, I've put in a 8mm ethos.
So why is that important to put like a higher magnification?
Because I want to get it as centered as I can, as close as I can. So I don't want to go too high power. It'll be very difficult to find Polaris, but high enough that I can put the star as close to center as I can and be confident that at higher powers using this eyepiece that I'm going to be able to track effectively.
Now behind you I see another piece of equipment. If I turn my camera here,
Yes.
and I would concentrate on this equipment here, it looks like a binocular. So can you tell me about this equipment?
This is a 100mm f5.6 Garrett optics. It's, I believe, the same unit that APM in Europe sells as their 100mm. They claim it's semi-apo, which, whatever that means, that's just one of those buzzwords everybody throws out and nobody really knows the meaning, but it sounds pretty good.
So Apple is for apochromatic,
Yes,
which is
apochromatic, which apochromatic means the absence of color, extra color.
so purple fringing
Yeah,
on
there's
bright
no purple
object.
fringing. The object looks like it should in its natural state. No optic is totally perfect, so you'll always find at the higher powers or at certain atmospheric conditions there will be some color show up, but in an apochromatic scope it should be very, very hard to detect.
So what's an advantage of having two eyes looking at an object compared to our single eyepiece?
Well, it's like if you close one eye and then walk around, you lose all depth perception. And the same thing with a binocular. If you have a binocular, you get depth perception. You get a 3D effect, and it also, two eyes are collecting light. So the object seems brighter. It seems more realistic, where you can just reach out and almost touch it.
No, obviously this is a lot smaller than your other one. So what kind of object can you see with binoculars?
With this one here, I'm not sure. This is the first time I've had it out. I just picked it up today. It's the last gentleman that had it traded it in for something bigger, as in scope-wise. But I find it's during daytime testing, it's been surprisingly good.
Yeah. So with normal binoculars or bigger binoculars like this, there's a lot of things you can see in the
Yes,
sky. You don't
because-
have to have a big
No.
scope like you have behind.
No, 100mm is that 4-inch aperture where a lot of astronomers will tell you that at 4 inches you could see more than you could visualize in a lifetime. So you could see all the Messier objects with 100, even less if you're really patient and very skilled and have the right atmospheric conditions.
So for those who don't know what we're talking about here, the Messier object,
Yes.
referring to Charles Messier,
Yes.
the French astronomer.
Yes.
So there is a list of objects that Charles discovered.
110, but I think 2 are duplicates. So there's really, say, 109.
So in this city, we can see a lot of those Messier objects.
Yes. In fact, a lot of the major cities in North America, most people have bagged all 109 or 110, whatever you like to call it. And I think it's possible under the right conditions. Here at 3,000 feet up on Mount Seymour, we're going to we'll experience a little bit of a light dome over the city because of the moisture levels. So it will reflect some of the city light. But we've been up here on some nights where the moisture level has been very, very low. And so there's no glow. We've been able to see the Milky Way, naked eye. And that just means that you can go deeper. You can see fainter objects because the city glow is not competing.
Okay, so when we're referring to object with the letter M, we're talking about Messier object.
Yes.
So let's say we talk about M13, a popular object.
That's right.
That would be the 13th object
Yes.
in the catalog.
Yes.
And that is a globular cluster that we could probably see later tonight.
Yes, and it's in the constellation Hercules. And so it's quite high in the sky, which is nice because the higher up off the horizon, the better the atmospheric condition because it's not going through as much of the turbulent air. So the objects overhead will actually show much clearer and with better resolution on most nights.
Okay, so it's easier too.
Yes.
So it's a pretty bright object. Yes. So we're talking about magnitude when we talk about bright. You can see it with a
pair of binoculars. In a dark site, you should be able to see it naked eye with good adaptation.
So it's pretty bright.
Yes, it's pretty bright.
So with the binoculars, you can kind of see the 3D effect of that object.
Yes, yeah. It's very faint, but under the right power and the right aperture, you can resolve a lot of detail in it.
Excellent. So all your equipment obviously require powers to make all of this work.
Pretty much, and if it doesn't require power, it requires dew control, which requires power, and dew control just keeps away the moisture forming on your corrector lens or the front of your objective. And what happens is when the temperature of the lens gets very close to the temperature of the atmosphere around it, it has a tendency to start absorbing moisture. Moisture will start to form.
So let's talk about why we're really here today, because obviously we're here for a reason.
Yes.
Because it's a clear night, obviously.
It's a clear night, and
but
we like to do outreach, and we're doing a 6-inch shootout.
Okay, so what's the 6-inch shootout about? So
well, we're going to test one of Roland Christian's 6-inch Apos. So this is an oil spaced, and the Esprit is an air spaced. So 2 different ways of aligning lenses, and both properly executed can give amazing results.
Okay, so what are you looking for when you do these shootouts?
We're looking for contrast, we're looking for detail on particular objects. The owners of these 2 scopes, myself and Stan, we brought our equipment, but we're going to have an independent person do the evaluation because it's only fair that somebody that has nothing in the game can hopefully make a better determination.
You mean an unbiased decision?
Yes.
So who's going to be the judge tonight?
We think it may be someone from Vancouver Telescopes, but they haven't arrived yet, so we're open to other contenders if they don't show.
So is it the same eyepiece are going to be used on the same scope?
I don't think so, but we're going to try to match the powers. The scopes are pretty much the same focal length and the same aperture, so powers are going to be very close, you know, within probably 1 or 2%, which is acceptable. Anything more than that, and you're starting to give an advantage to one scope or another. So we're going to try to match as best we can focal length, types of eyepieces, and try to make this a fair contest.
So your scope was made in which country?
This was made in America.
Okay, so this is an American-made
Yes.
telescope, and stand scope here?
That is made in China.
In China.
Yes.
So China has improved over the years
Yes.
over manufacturing. They probably manufacture 90% of all scope in the world.
Yes, and this is their foray into the upper echelons.
There he is.
Yeah,
How you doing?
pretty good. How are you?
Good.
So, hey Klaus. So, tell me about your setup here that you have.
Well, got an HEQ6 mount and Skywatcher 7-inch Maxitov Cassegrain.
So, what's the difference between your Mac compared to the other scope we saw before, like the refractor or the Dobsonians?
Well, it's a compound optic telescope, shorter tube, and more stable.
More stable. So, what's the focal length of this telescope?
See you, Andreas. 2,700 millimeters.
So that's pretty long compared to all the other scope we saw before. So
Yeah, it's f/15.
okay, so there's less light, but you have a bigger image.
Right.
So a narrower field of view
Yeah.
when you look in the sky. So
Yeah.
why is that good for things like planets, for example?
Well, because you have a higher magnification without using shorter eyepieces, shorter focal length eyepieces.
So the planets are bigger.
True, yeah. And with a Maxitov, you have quite a good sharp image, almost like a refracting telescope.
Because of the F ratio, right? So there's better
Correct.
color correction,
Yeah. You got it. Yeah.
less fringing, right? The
Correct.
purple thing
Yeah.
around
Yeah.
the colored,
Yeah.
image.
That's right.
Now, when you have a Maxitov like yours,
Yeah.
there's also disadvantage, right?
Yeah, well, faint deep sky objects don't come through as well.
It's also harder to find objects in the sky because you're seeing, a narrower field of view.
True, but I make sure my finder is aligned very well. So not
That's the
really-
trick then.
Not really an object.
And your computer that you have on your
Yeah,
Mac.
and I'm meticulous in the alignment so that the computer can find the things without too much difficulty.
So Keith earlier talked about polar alignment. We're about, let's say, an hour from polar alignment.
Yeah.
So what's your trick to align your scope correctly with the North Star?
Well, I use the polar finder scope, of course. Once I have it, I have a look at my computer where it says where it should be as far as the clock face. If it says Polaris should be, say, at 8 o'clock, you put it in the circle where it would be 8 o'clock, and you're basically pretty close, probably 99.9% aligned.
That's pretty good. So in order to do that, I'm guessing you have to enter GPS coordinate in your
Well,
in your mount.
mostly the time. You don't need a GPS.
Oh, the time.
The local time of day.
The time zone.
Yeah. Time
And
zone
the time of
and
the day.
time. Yeah, the correct time. And
Okay.
date, of course.
So for doing after your polar alignment, you need to set up your what we call the go-to computer.
Yeah.
So what do you do to set that up?
I usually use a 3-star alignment.
Okay, so for those who don't know what a 3-star alignment is, can you elaborate a
Well,
little for
yeah,
us?
you have a choice of a 1, 2, or 3-star alignment, and of course, 3-star is better as opposed to a 1-star. And what it means is you go from the home position where this scope is right now, and the computer will tell you which star it's going to go to. and usually you can see it in the finder scope right in the beginning, and you fine tune it till you have it in the center. Then it will go to the second star, and you repeat the same procedure, and finally to the third star. You do that again, and it will tell you whether you've been successful or not, and if you are, you're ready to go.
So this is to help the computer to refine the tracking of where each objects are in
Correct.
the sky.
Yeah.
So with 3 coordinates in 3 different south, east, or north,
Yeah,
that helps you with the mount and precise to be
Yeah.
more precise when you
yeah.
go with the
As long
go-to.
as the polar alignment, the initial polar alignment is correct, and the computer usually has no problem finding things.
So that's good for people who are beginners, who really don't know all the object.
Correct, yeah.
They can use the guide in the computer.
Takes the frustration out.
Take
So
the
it becomes fun.
So
It's
every
supposed to be.
beginner can go and do stargazing. Once they do, you know, they know a couple stars to align to.
Yeah. It's supposed to be enjoyment, not frustration.
Shooting in the sky, or no?
Well, people do take pictures, yes. I want to, but I keep having glitches and problems, so I'm working on it.
Oh, okay.
So how big again is your Dobsonian telescope?
20.
20 inch.
Yeah.
So how long does it usually take you to get this piece together?
Not too long. The more I use it, the better I get. I just don't get out as much with the weather we've got here on the wet coast.
Yeah. So has anyone here ever seen anything questionable in the sky?
No.
No?
I haven't. I don't know.
No, you haven't? Okay. I always like to ask the experts that are, you know, because there's the other people who are like, look what I see, you know, it's like YouTube. It's like, okay, what is that?
This
For
is
people that actually spend time staring at the sky.
It's not Texas here, right?
Yeah, no, that's right. That's right.
We don't go on TV to say that we saw a UFO every hour.
Right. I think there's so many things up there that are confusing, and we know what they are. At the end of the day, that's fascinating enough. This is really cool.
To move, so I finally got it to move, and I got it to start to turn, and then I got it about 15 turns. Cries every time I see that scope, and there's good reason. Very, very happy, Robert, with that scope. That's the nicest 4-inch I've ever looked through, except for maybe talk to me about spending money.
So how long have you had this scope?
What, this one?
Yeah.
4 years.
And did you build a box manually, or you order everything?
No,
And
it comes from Obsession telescopes.
They're pretty bad here tonight. But they're not really mosquitoes, they're something else.
And do you have a digital encoder, or this is just purely manual?
No, it's got a digital encoder and it's got servo cat drive system. So it's go-to tracking.
Yeah. So, hi Christine.
Hi Claude.
So, as you know, I'm filming today, having fun. So, we just want to talk about your scope.
Okay.
So it's a little bit different from all the other scope I've seen so far. So, tell me about your scope.
Well, have you had a look at some of the other Dobsonians tonight?
No, so we saw the big one, but
Right.
I want to show a smaller scope, which is affordable for everyone to get.
Absolutely. This is the smaller, simpler, more affordable version of some of the ones you've probably looked at. Like all of the other Dobs, what's happening is the starlight's coming down and hitting the primary mirror on the bottom, reflecting up to the secondary inside here, and then out the eyepiece got over on the side here.
So excellent. I see that you have a special eyepiece on your scope.
I have a click zoom eyepiece, so with a single eyepiece I can change from an 8mm eyepiece to 24 just by clicking around.
So for those who don't know what that means, the eyepiece is the millimeter. So the higher number, the wider the image is, right?
That's right. Typically what you're doing is taking the millimeter measurement of the eyepiece and dividing your focal length of the scope by it, which gives you your magnification.
So I see yours is decorated with this is some nice stickers on it on top of that.
Yes, a little bit with my fascination with space and space exploration.
And so how much does something like this one cost?
You know, I'm not exactly sure what this is now, but I think this is probably just under $900 or so.
So that's a 10-inch version, right?
This is a 10-inch.
So there is
yep.
smaller version of this scope.
Sure, there's a lot of 6s and a lot of 8s out there.
So it's pretty affordable. It looks also that it's easily you can put it back in the car and mount it very easily.
It takes me about 1.5 minutes to set up, whereas some of these people with their fancy electronics and all their accessories takes them an hour or so to get going. This is really basic. With it, I'm not doing a lot of deep sky photography. It doesn't have the motors to track deep sky objects that I might be looking at. But on the upside, it has forced me to learn my way around the sky the hard way.
Yeah, so you have to know where the objects are located.
Yeah, I'm starting to think it's becoming a bit of a dying art with the electronics becoming so popular.
So you're one of the old school people.
I am old school, yeah.
So I see often you have your sky chart that you use.
Yes, absolutely. I've gone through a lot of different sky charts, but Sky Intel's Pocket Sky Atlas, love it. Very convenient. And really opened up the sky for me.
So can you give us some tricks, some people that start to do stargazing? How do you find object with your sky chart?
Well, what you'll do is you'll look for the primary stars that everybody can see, the ones you recognize. You'll start with something like the Dipper and you can look in the book and you can look at the Dipper and you can start star hopping. You pick a couple of stars that are maybe kind of in a line with something that you're looking for, and you just start star hopping.
Okay, so star hopping is going from a bright star to one that's adjacent to the one you looked before until you get to the object you want to get to.
Right, you're using obvious stars to help point and jump your way towards the fainter ones that you might be looking for.
Yeah, because it's difficult to just point it directly and get it the first time.
Oh, absolutely. I mean, everything's just up, right? And you know, I use stars for lining up what I'm shooting for. I'm usually not looking for other stars. I'm looking for a planetary nebula, or my favorite thing to go for.
Planetary nebula, so what is that?
I'm probably not the best one to give you a great definition of that. My understanding is because what we're seeing is, instead of just a star, you're seeing a bit of a glowing ball, and it's typically a star that's begun its dying process and has puffed off its outer shell of gases. And
so it's a different interesting object that usually blinks. And I know you're the expert on planet nebulas.
Well, a couple of them are known to blink, and that's usually an optical illusion, because what's happening is you've got the central star, and then you've got the puff of gases outside of it. So when you're looking at some of these, they're known to blink because your eye will play tricks on you. It'll focus first at the star in the center, and then on the entire object, gases included, and back to the star. And that's just something our eyes will do sometimes. And it depends on the seeing, the transparency, and which object you're looking at.
So not all the photon hits are retina at the same time also, right?
That's right too, yeah.
So it's kind of the optic illusion that it's blinking.
Right, exactly. And when the photons do hit your eyes, as with anything in the sky, some of these photons have been traveling for just millions and millions of light years before it ends up bouncing into your eye, and that's kind of neat. It's kind of the time traveling part.
It's a time traveling, so for those who don't understand this concept, is that the light takes so much time to travel that by the time it gets here, X amount of time has passed. So when you look at these planet nebulas that are millions of light years, then you're looking a million years in time.
Something like that, yeah.
Something like that?
yeah, exactly. The objects, the further away the objects we're looking at, what you're seeing right now might be the way that it looked, I don't know, 100,000, hundreds of thousands of years ago, depending on how far away it is. So sometimes we could be looking at something that in theory might not even still be there.
We only know based on the distance that it is, if it's no longer there or not.
Exactly.
All right, thank you, Christine. Perfect. So, Ian.
Hi.
So, welcome to this little video again. So we know each other on Facebook, obviously, but so tell me a little bit more about your equipment you have tonight.
Well, this is an 11-inch Schmidt-Cassegrain Aplanic Edge telescope. It's a mirror-based telescope. It's 11 inches in diameter, and it's on a EQ6 mount. I have a couple cameras that I use with it, and basically I'm up here to, much as I can, photograph whatever's in the sky.
Okay, so this is a motorized mount, obviously. So you're talking about cameras. So you're going to do photography tonight? Is that your plan?
Hopefully, yeah. It depends what the sky's like, but that's my plan. I have a modified Canon DSLR that will connect to the telescope, and using a computer, a laptop, I can do long exposures once I have the mount aligned properly, and it'll take pictures for several hours. Yeah.
So you're going to do longer exposure with your... So for those who don't know what the modified camera is, so can you tell me a little more about that?
Our eyes are very... when we look at things, we don't have to see the infrared light that's given off. Our eyes naturally filter it out, but the camera CCDs are sensitive to it. So most photographic cameras have a sensor, or a filter, in front of them that blocks out that infrared light, so it doesn't kind of expose all of our pictures in being red. Modifying a camera is just removing that filter, putting something else in its place. It can be a piece of clear glass, or it can be a hydrogen alpha filter, or something to block out any light that we don't want, but save all the hydrogen or the infrared light that we do.
So it's to replicate our eyes, basically, right?
No, actually it's not. It's to try and keep as much of the light that's in space onto the camera. In our eyes, we naturally filter out some of that light. We don't need it. But a lot of the nebulas actually glow very strongly in infrared or near infrared, and that's what we want to put in the camera.
It's more like on the red spectrum of the wavelength. So Now, why is it important that you do longer exposure? Can we just take just one snapshot and get the galaxies in the camera?
If something's really bright, like the sun, the moon, most of the planets, you can just do really quick pictures. But long exposures are necessary for anything that's really faint because they don't show up very well in a simple photograph. What you need to do is gather as many photons as you can by taking, usually they're 20, 30, 40-minute pictures and then combining them in some sort of computer program.
So you take your captures and you go at home and then you try to combine all these exposures together.
Well, there's lots of different ways you can take pictures. You can do one long exposure of 50 minutes or an hour. The problem with that is a passing car or an airplane that runs through the field of view will both ruin an entire 50-minute picture. So instead what we do is we take sub-exposures of 5 minutes or 3 minutes or something and then stack all of them together in a computer.
So no more satellite tracing in your pictures.
Exactly. Although there are ways you can remove those in Photoshop.
Now, I noticed you have an Edge, a C11, so these are a little more special than a regular Cassegrain telescope.
Yeah.
Can you...
Well, the whole impetus for me to get this telescope was the limitations imposed by the regular Cassegrain. They have a very curved field of view. When you look through an eyepiece, you naturally see dots because our eyes adjust and kind of can make minor focusing adjustments and help us to see things clearly. Cameras can't do that. The problem with the old telescope, the old Celestron that I had, was it has a very curved field. So the very center is going to be nice and focused and sharp, but the outer edges of it will be big blotches and it's very, very hard to focus. This, on the other hand, is called aplanic, meaning it's got a nice flat focal plane. It's still not completely flat like you get on a Rishi Crescent, but it's much, much better, and it's actually quite suitable for the photography that I want to do.
So on top of that, also, you can put the camera in front of the lens.
Right. It's called a hyperstar. I want to try it, but the problem is I'm concerned about the profile of the Canon camera that I use, because it's actually quite... if you have a smaller, like a dedicated astronomical CCD camera, it's a circle, first of all, and it's a small profile. The Canon camera is very similar to the one that you're filming this on. It's quite big, and it'll actually block out a fair bit of the aperture of the telescope, and it's not uniform.
So for those who don't know, Cassegrain, they have a central obstruction to allow the light to be focused.
Right. It's similar to a Newtonian, only it's not bouncing the light out to the side. It's bouncing it straight back down the central mirror. A hyperstar would be putting a camera in place of the secondary mirror. And I'm a little bit concerned about doing that with the setup I have because I don't know how well a Canon camera is going to take the place of that hyperstar camera CCD.
So blocking more light that you really wanted to.
Yeah. Well, the other problem too is the Canon camera is not uniform all around. It has a very rectangular kind of odd shape, and that's going to give some very interesting diffraction patterns in my image. And I don't really want to spend the money to try to see how it'll work because it may not actually work well at all.
So this is a f10, I'm guessing.
It is, yeah.
So what focal length is this telescope?
This is about 2,300 millimeters. It's quite a long focal length. The last one that I had was 2,000 or 1,800. Because again, since it's basically a folded telescope where the light comes in through here, bounces off this mirror, bounces off a mirror here, and then comes out the back. So the focal length is actually 3 times the length of the tube.
So it allows to have a more compact telescope.
That's the big benefit of Cassegrain telescopes is they're very compact. Unlike a Newtonian, which tends to be very tall, these are much more portable. The downside to them, though, is they tend to give a very narrow field of view. So unlike refractors, which will give you a much wider swath of the sky, these are very, very narrow.
So when we start astronomy, we want to see things bigger. So obviously the Cassegrain is a great telescope, but as we do more with astronomy, we kind of want to see wider.
Yes.
So this is more specialized in planet or fainter objects.
Yeah, there's a lot of stuff you can see with it because a lot of the galaxies are actually quite tight. Unless you go to something like the Andromeda Galaxy or Triangulum, the galaxies themselves are quite small. But I do have another telescope, a Teleview 85 millimeter that gives me beautiful wide field pictures, and I actually like using that more for photography than this because focusing is easier. The exposure times don't need to be quite as long because it's a faster telescope, and it's just all around a really, really nice scope to
And
use.
your tracking doesn't have to be as
That's
accurate
true.
also.
That's true. Yeah. I do have, for both of them, I do have an auto guider that I can use, but there's limitations to what an auto guider, how much an auto guider can you actually correct.
So we haven't talked about auto guiding yet. So talk to me about why is that important when you do long exposure?
Well, the idea for long exposures is to compensate for the rotation of the Earth. If the mount is not directly oriented to within about half a degree, ideally less than that, a few arc minutes, of Polaris, it becomes very, very difficult to get long exposures done well without all the stars and the light starting to trail. An auto guider can help compensate for that. So it'll be connected to a separate telescope on the top of this one that then it basically takes pictures and it'll record when a star moves. And as a star moves, it'll send a signal to the mount to move it back where it should be. And so essentially it's keeping the same star fixed in the same position.
So even when you do use an auto guider, the polar alignment still is important,
It
right?
should be, yeah. Ironically, what I found is as you go up in focal length to something like this, it becomes less important because the big problem with having an auto guider on a poorly aligned telescope is field rotation. So the center will stay nice and stable, but all the outside parts will start to trail in one direction or another. But because this has such a tight field of view, it will still happen, but it's outside the field of view of the telescope. But it's a much bigger problem on the Teleview 85 that I use. If my polar alignment's not almost spot on, you'll start to see it on anything longer than about 15 or 20 minutes of pictures.
Okay, so thank you, Ian, for your time.
You're welcome. You're welcome.